It was the final chapter of one of humanity's greatest journeys to Saturn. In September 2017, the Cassini spacecraft entered Saturn's atmosphere and transmitted its final signals before disappearing forever. But Cassini's destruction was not a failure. It was the carefully planned ending of a mission that had spent years transforming our understanding of Saturn and its extraordinary collection of moons and rings. Before Cassini arrived, Saturn was mostly known for its magnificent rings. Scientists knew the planet was enormous, but many details about its atmosphere, magnetic environment, rings, and moons remained mysterious. Cassini changed that picture completely. During its mission, the spacecraft observed gigantic storms, studied Saturn's magnetic field, examined the complicated ring system, and explored worlds that turned out to be far more interesting than scientists expected. Its final phase was called the grand finale. During this period, Cassini repeatedly passed through the narrow region between Saturn and its innermost rings. No spacecraft had explored this area in the same way before. The spacecraft gathered measurements of Saturn's gravity, magnetic environment, atmospheric composition, and the materials surrounding the planet. It also captured remarkably close views of Saturn and its rings. Then came the final dive. Cassini was deliberately directed into Saturn's atmosphere because scientists wanted to prevent the spacecraft from accidentally reaching potentially habitable moons in the future. The mission ended, but the information it collected did not disappear. Cassini left behind an enormous scientific archive containing images, measurements, and observations collected over many years. And this creates an exciting possibility. As technology improves, scientists can return to older spacecraft data and examine it using newer analytical techniques. Modern machine learning systems can process enormous datasets and search for subtle patterns that may be difficult to identify manually. They can compare images, measure changes, classify structures, and search for relationships across huge collections of observations. That does not mean artificial intelligence automatically discovers something mysterious or artificial. In planetary science, strange-looking patterns often have completely natural explanations. Saturn itself provides a perfect example. Near its north pole is a gigantic six-sided atmospheric pattern known as the hexagon. Its shape looks almost impossible at first glance. But research into fluid dynamics has shown that rotating atmospheric currents can naturally create remarkable geometric structures. Saturn's atmosphere is filled with powerful interactions involving rotation, pressure, temperature, and chemistry. So unusual patterns should be investigated carefully rather than immediately treated as evidence of something artificial. Cassini's real discoveries are already extraordinary. One of the most important came from Enceladus. This small icy moon was expected to be cold and inactive. Instead, Cassini detected plumes of water vapor and icy particles emerging from fractures near its south pole. Further observations provided strong evidence for a liquid ocean beneath the moon's frozen exterior. That discovery transformed Enceladus into one of the most interesting places in the solar system for studying environments that might potentially support life. And Enceladus was only one part of Cassini's story. Another world would prove equally fascinating. Titan. Titan, Saturn's largest moon, turned out to be one of the strangest worlds ever explored. It has a thick atmosphere and an active weather system. But its surface is not dominated by liquid water. Instead, methane and ethane form rivers, lakes, and seas across the moon's surface. Titan demonstrated that a world can be completely different from Earth while still possessing an incredibly complex environment. Cassini also changed the way scientists understood Saturn's famous rings. They are not simply enormous bands of frozen material surrounding the planet. The rings are an active system. Gravity constantly shapes them. Particles collide and move. Saturn's moons interact with the ring material, producing waves, gaps, and other structures. The entire system changes over time. This was another important lesson from Cassini. Planetary systems are not frozen scenes. They are dynamic environments that evolve continuously. And even though Cassini's mission ended in 2017, its observations can continue to be useful. Scientists can revisit old measurements with improved computer models and modern analytical techniques. Machine learning may help researchers organize enormous archives, compare observations from different periods, and identify subtle variations that deserve closer examination. For example, researchers could investigate long-term changes in Saturn's atmosphere or examine how ring structures evolve. They could also search for connections between Saturn's moons and their surrounding environment. But it is important to separate real discoveries from speculation. There is currently no verified evidence that Cassini discovered artificial structures, extraterrestrial technology, or hidden alien signals. The genuine scientific story is already remarkable enough. A spacecraft built by humans traveled billions of kilometers, entered the Saturn system, survived years of exploration, and returned an extraordinary amount of information. It revealed active worlds where scientists had expected frozen landscapes. It found evidence of a hidden ocean beneath Enceladus. It showed Titan's methane cycle and revealed an environment unlike anything on Earth. It examined Saturn's rings in unprecedented detail and demonstrated how gravitational interactions can reshape an entire planetary system. And its final moments were scientifically valuable as well. The grand finale allowed Cassini to investigate a region between Saturn and its rings that had remained unexplored. The spacecraft continued sending measurements almost until the very end. Then its signal disappeared. Cassini was gone. But its scientific legacy remained. This is one of the most important ideas in space exploration. A spacecraft does not stop being useful simply because its mission ends. Its data can continue answering questions for decades. New technology can reveal information hidden inside old observations. New scientists can approach familiar data with completely different questions. And artificial intelligence may become another tool for searching through these enormous scientific archives. The future discoveries may not be dramatic signals or mysterious artificial structures. They may be subtle changes in Saturn's atmosphere, previously overlooked patterns in its rings, or new clues about the evolution of moons and giant planets. That is what makes Cassini's story so powerful. The spacecraft may have disappeared into Saturn, but the knowledge it gathered continues traveling through humanity's scientific community. Saturn remains a world of enormous storms, spectacular rings, complex chemistry, and fascinating moons. Cassini showed us that the more closely we examine the universe, the more complicated it becomes. Its final transmission was not the end of the story. It was the closing signal of a mission whose discoveries may continue guiding planetary science for generations. Cassini is gone. But the questions it left behind are still alive.